All right, let's keep on crack-a-lacking through this. So what we're going to do now is I pulled up right here the perfect squared numbers, and I put some perfect cubes and some perfect fourth powers. Perfect square just means I take 1 and I square it, take 2 and I square it, 3 and I square it, 4 and I square it. So these are called the perfect squares. These guys are called the perfect cubes. I take 1, I cube it, 2, I cube it, 3, I cube it, and do the same thing with the power of 4s. Okay, so what's the purpose of that, and why are we doing this? Well, what we want to do now is when we start to throw in radicals that have indexes that have 2, 3, or 4, or 5. I mean, really the index can be any number. The perfect squares and perfect cubes and perfect fourth powers really come into play into simplifying the radicals. Okay, so what I want to go through right now is a few examples now of how do you simplify radicals, and these guys right here are going to play an important role, and let me show you what I mean by that. Okay, so let's look at example 4a. All right, and we want to do is that we want to take the square roots of 32. And you may actually already know how to break down radicals, but if not, this would be a cool review here. Okay, so breaking down radicals, or basically meaning, when I say break down, I mean just simplify this, because you can rewrite this in a more in a simplified way. It's kind of like having a fraction like 8 over 6, right? I mean, you don't want to leave a fraction as 8 over 6. You want to write that as 4/3, right? So in the same way, we want to rewrite radical 32. So let me show you what I mean by that. Okay. So this is how we break down radicals. Okay. So notice that the index right here is a 2, right? It's a 2. So since this has a radical 2, watch this now. We're going to be looking at our perfect squares. And what we're looking for is this. Watch this now. We're looking for the biggest perfect square number, like 4, 9, 16, 25, 36. We're looking at just the perfect square numbers, and we ask ourselves this question: which perfect square number, and not just which perfect square number, what is the biggest perfect square number that divides into 32? 4. Does 4 go into 32? See, yes it does, but is that the biggest? And the answer is no, it's not the biggest. So not 9, but 16. See, 16 goes into 32, right? So watch this now. So the way that you rewrite this is we're going to write this as a product. We're going to write it as a product of two radicals. So what times what gives us back the square root of 32. Okay, one of these has to be the biggest perfect square. Okay, and we just said it was 16, right? So square root of 16 times square root of 2, doesn't that give us square root of 32? Right? Yes. So now, what is the square root of 16? It's 4, and then we're going to leave that as square root of 2. Okay, so what is this whole thing about simplifying now? Okay, notice that I said I want you to find the biggest number, and I'm going to go over at the end of these exercises why you want to try to find the biggest one and what happens if you don't. Okay, like I'll cover that here in a moment. But the reason why that I leave it as 4 radical 2 is the square root of 2 cannot be simplified anymore. Because watch this, if I go to my perfect square numbers, excluding 1, because 1 goes into every number, does 4, 9, 16, 25, 36, and so on, do any of those numbers go into 2? No. Yeah, right, no, it doesn't. So that's why we leave radical 2. But if you come back up here, square root of 16, you see, is one of our perfect square numbers. So I can break that down or simplify square root of 16, but I can't simplify radical 2. So this right here would be our simplified answer of square root of 32. Okay, well, watch. If you see more examples, it may become much more familiar then. Okay, so I know that I want to write this as a product of two radicals, okay? Now, which perfect square number, mind you, the biggest perfect square number that goes into 300? 100, right? 100. So that means I would say 100 times 3, right? Square root of 100 times square root of 3 is 300. But now, what is the square root of 100? 10. And we cannot break down square root of 3. Because look, none of these numbers goes into 3. So this right here is our simplified answer. Okay. Let's go to square root of 35. Okay, so I'm going to write this as a product of two radicals. Which number, again, we don't include 1, which perfect square number goes into 35? 4, 9, no, 16, 25, 4 number too big. Well, none of them do. So that means that this is not simplified. Like, you can't simplify this. This is the answer. The square root of 35 is the square root of 35. This is not, you're not able to simplify it. Okay? Let's move on down here to this guy right here, the third root of 54. Okay, watch this now. A, B, and C have been square roots. Part D is a cube root. So when I find my answer, I'm going to write a product of two cube roots. So cube root of what times the cube root of what is 54. It's the same thing, meaning go to our perfect cubes, which is the biggest perfect cube that goes into 54. Let's see, 8, 9, 27. Oh, yeah. Doesn't 27 go into 54? I think so. I think so right there, right? Okay, so that's going to go into it 2 times. So I can put cube root of 27 times 2, right? Here's 27. So 27 times 2 gives me back 54. So, but wait a minute. What is the cube root of 27? That right there is going to give us 3. And can we simplify the cube root of 2? Well, again, like, do any of these numbers go into 2? Not including 1. Well, no, right? So that's why you leave this as times the cube roots of 2. And that's going to be the answer right there. 3 times the cube root of 2. Okay. Coming over here, now we're doing the fourth root of 243, meaning I want to write my answer as a product of two radicals, the fourth root of something times the fourth root of something. Okay, so let's come up here. So the fourth root of what times the fourth root of what is 243. Okay, so let's, again, we ask ourselves the exact same question. What number up here, the biggest number, goes into 243? Well, I mean, isn't it 81, right? So that means 81, okay, right here. 81 times 3. 81 times 3 is 243. And what is the fourth root of 81? Well, look, the fourth root of 81 is just 3, right? I mean, we have the answer right there. Okay, so that's just going to give us right here 3. And then no, we can't break down or simplify the fourth root of 3. So we leave it as the fourth root of 3. Okay, so I said that I was going to explain to you what happens if you don't choose the biggest number. So let me show you what happens here. Okay, so what if we didn't factor the greatest term? Okay, and so check this out right here. All right, so let's just first do it the way that I taught you, and then I'll show you the other way, what happens if you don't find the biggest one. All right, so that means we want to write this as the square root of what times the square root of what. And the biggest number that goes into 108 is, let's see, is that 36, I believe, right? Yeah, so 36 and 3. And square root of 36 is 6 radical 3. Okay, so that's our answer right there. Okay, but say if we didn't choose the biggest number, okay? So meaning, what if we said, oh, well, you know, let's see, 4 goes into 108. So what if I said square root of 4 times square root of 27. Okay, what I want to show you is that we're going to get the same answer, but we have to work a little harder. Watch this. It's true that 4 times 27 is 108. Okay, and again, one of these numbers has to be a perfect square number. Okay, so 4 is a perfect square, even though it's not the biggest one, but it's still a perfect square. Square root of 4 is 2. All right, but now watch this. Okay, now we have to break down the square root of 27, meaning we have to ask ourselves that question: what is the biggest number now, or what's a perfect square that goes into 27? Well, wouldn't that be square root of 9 times square root of 3? Right? Once again, anytime that you simplify a radical, one of your radicals has to be a perfect square number. So now, square root of 9 is 3. So that means I drop down the 2. This right here is a 3, and that's times radical 3. And 2 times 3, 6 radical 3. Oh, bing! So you can see the work here, how it takes a little more work to do the right side than it was to do the left. And that's why it is suggested that you always find the biggest square or cube number or whatever it is the index is when you're simplifying these radicals.